So on the next set of slides, we're going to look at current changes versus historical changes and the case for human causes increasing the number of greenhouse gases and having these effects on climate and other global changes. So first, I again want to point out to you the NASA website, which is linked here. It's a very good website for having the most up-to-date information and the most clear data. Okay, so first we're going to look at global temperatures since 1880. And these have been averaged. So here on the x-axis we have the year 1880 all the way to 2010. And temperature anomaly in degrees centigrade means that if you look at an average temperature in, say, 1950, how much lower was it on average in the years before that, and how much lower or higher was it in the years after that baseline. And you can see that the trend is certainly upward in increasing temperature. Since 1880, temperatures have risen 0.8 degrees centigrade. That is the same as 1.4 degrees Fahrenheit. That's through 2009. Looking on the November 2020 data on NASA's website, it has now risen to 2.1 degrees Fahrenheit by 2020. So it's another degree warmer in basically the last decade. And just a little side note, solar radiation has actually decreased, not increased. So we know that's not one of the causes. Now, one of the tricky things about this is that the change in temperature is not consistent throughout. And if we look at this graph here, we have 2009 surface temperature data plotted on the map to represent differences relative to the average temperature from 1951 to 1980. And so the more orange and red, the warmer it is in degrees Celsius. And the more blue and yellow, the less severe the changes are. So look at the graph and see where is it warming the most. It's warming the most at the northernmost latitudes, right? The North Pole area. So scientists aren't completely sure of why that is, so they're still working on that mystery. But one of the problems with it is that if you're in the Arctic area, which had a lot of snow and ice cover, which used to reflect the sun, and then it starts melting, so you have thinner ice, you have less ice extent, then you're reflecting the sun's light back less and less, which means more and more heat would be absorbed in those areas. So again, it's a positive feedback loop where the more it warms in the Arctic, the more the ice and snow melt, and then the warmer it will get. So now we're going to look at the relationship between carbon dioxide and temperature. And to do that, we are looking at a graph that goes back from, based on ice cores in particular, that goes back in time from present day, 100,000 years ago, all the way back to about 400,000 years ago. And they looked at these ice cores, and in purple here, they measured the amount of CO2 that was in the ice core that is associated with these time periods. So as you see, the purple had periods of time where it peaked and it had valleys, more peaks and valleys, peaks and valleys, peaks and valleys. Now on the right hand side, we have in the blue, the temperature change in degrees C compared to present day temperatures. So that would be based on other data such as the foraminifera that I mentioned or leaf shape. So as you can see, when the CO2 was high, the temperature was high. when the CO2 was lower in concentration, measured in parts per million, then the temperature was also lower. And they seem to coincide, pretty well-fitting glove in hand here, where when one is up, the other's up. When one is down, the other's down. Now, it does beg the question, which came first, the chicken or the egg? So was it that CO2 was high, and that's why, CO2 is high, and that's why temperature was high? CO2 was low, and that's why temperature was low? Or was it that the temperature was high, and therefore the CO2 was high? However, when you take into account the chemical fact that CO2 is a greenhouse gas, that within its molecules it takes in energy and re-emits it as infrared energy, it would seem to indicate that it's the CO2 which is causing the temperature change. Now we have some more recent data about CO2, so let's take a look at that. Okay, so a man named Charles David Keeling began measuring carbon dioxide back in 1958, which is the year shown here on the x-axis. And this graph shows the measurements of CO2 all the way through to 2010, and then I'll update you on current levels. So on the y-axis we have carbon dioxide in parts per million, and so when he first measured it, the carbon dioxide parts per million was at 320 parts per million, and by 2010 it was at, let's say 390-ish, and it continues to increase every year. So first, let me point out to you, we have the overall trend in the blue line and the monthly average in the purple line. So you can see within each single year, there's a rise in CO2 and a drop in CO2. What do you think that causes that? What happens where, there would be less CO2 in the atmosphere? Well, that would happen in the summertime, or spring and summer, and less in the winter. Because when we have more trees to take in the CO2, it will cause a slight decrease in the values. But nonetheless, so that's why it's going up and down, but even as it goes up and down, as you can see, the numbers continue to increase. Now, this graph, again, shows that timeline all the way from current time, which in this case was 2010, and looking backward over the past 400,000 years at the CO2 in parts per million. And you can see that there are peaks and valleys. But what has happened since in recent times? So it's gone up to where the peak is, and based on the other peaks that we have seen, one might expect that we would start to experience a decrease, and we could actually go into a colder period. Well, I shouldn't say colder, in this case, in a period of time with lower CO2 levels. But in fact, that's not what happened. So currently, the CO2 levels have actually now exceeded the 400 mark. So we're just continuing to go upward like this. Now, we'll revisit this, but at this time it would be a good idea for you to hypothesize just how high our CO2 levels have gone. So let's put together a few things. We know that an increase in CO2 levels in the atmosphere causes a greater capacity for warming through the greenhouse effect. So we know it's a fact that increased CO2 levels in the atmosphere causes a greater capacity for warming through the greenhouse effect. Now, when the Earth experiences higher temperatures, the oceans warm as well, and so they can't contain as much CO2 gas as they normally would. So, in fact, since 1969 to today, our oceans have increased in temperature 0.6 degrees Fahrenheit. And while that may not sound like a huge number to you, it does lead to a number of complications, including ocean acidification. Since the Industrial Revolution, the acidity of surface ocean water has increased about 30% because the oceans absorb about 25% of the CO2 emissions that humans have created recently. So as they warm, we go into this cyclical cycle. The ocean gets warmer, and then as a result, they release some of that CO2 that they've been holding on, it releases some of that CO2 that had been held within the oceans. And it becomes a cyclical effect. A warmer earth causes the ocean to release more CO2. The higher the CO2 concentration in the atmosphere, it warms the earth through the greenhouse effect, and this causes a release of yet more CO2, and so on.